Hi, I'm Allan Ross. I'm the managing editor of APC Technologies. We are at the IEEE PES Grid Edge Conference, one of the sponsors of these interviews. Our other sponsors are Dynamic Ratings and H2 Scan. Enjoy these interviews. My next guest is Seamus Allan. I've done Seamus before, but not in a live format. Seamus, we were actually on Zoom. He's the product portfolio manager for Dynamic Ratings, who's one of our sponsors and a great friend of APC Technologies. Seamus, thanks for joining us. First question I've got to you is, I sent these out, but tell me something about yourself that nobody knows, but you don't have to tell anything that's like so private. Your wife goes, you shouldn't have said that. No, I'm kidding. No, tell me a little bit about your background with Dynamic Ratings.
Yeah, so I started with Dynamic Ratings a little while after I did my university degree in New Zealand. And to be honest, when I was at university, I had no interest in the power industry whatsoever. I was terrified by the induction machine subjects we had to do. It was way too hard for me. Yeah. And I did computer programming, software engineering, and that's kind of how I got into Dynamic Ratings as a software engineer. And I've been there now for about 15 years, which is much longer than I had anticipated. And
Still living in New Zealand?
No, I left New Zealand pretty much straight after university, which is what most Kiwis do, is they escape and they live. And since then I've lived in Australia, the United Kingdom, in Wisconsin, and I'm back in Australia now. So moving around a little bit.
And Dynamic Ratings is growing, I know, so having a global offering is very important. Okay, the first thing I want to ask you, define for me, because everybody's going to do this differently. When I say grid edge, what does that mean?
Yeah, it's a good question.
Yeah.
Because I think, as you say, it's going to have different connotations to different people, and it's been changing over time. So grid edge used to be the low voltage part of the network, probably the point of connection to customers might have been the grid edge, a little while ago. And nowadays I feel like that grid edge is becoming more blurry. And we're seeing in countries like Australia quite a transition from the really strangly thin parts of the network, which were the grid edge historically, actually been chopped off and put into standalone power systems using innovative renewable technologies or diesel technologies to try and trim that back a bit. But I guess the edge of the network where we're seeing the load increases occurring and a lot more generation going into the network there. So I sort of think it's still kind of that low medium voltage part of the network, but I think more generally speaking, the concept of a grid having centralized generation with energy flowing out to an edge, that picture is changing now to generation being spread all over the place and being shifted sideways and up and down in all directions. So,
which brings me to a point: how much is electrification of transportation going to change the grid edge? Because as you said, it was the low voltage side, but now you've got wind and solar at the grid edge coming back in for generation. How much is electrification going to change the grid edge?
It's going to be phenomenal.
I love that word. Good, thank you for saying that.
The forecasted growth in demand because of electrification of transportation alone in Canada, Australia and the UK, they're predicting a 40 to 50% electricity demand increase based on EVs alone, based on electrification alone, just of transportation. And so you can imagine that you're putting this massive amount of load at the edge of the network, I guess, where it traditionally, the network was designed to support houses with maybe a stove or a microwave and some appliances, and now it's going to have a big charger there. And so that's going to have a massive impact. And the amount of augmentation that's going to have to happen to the network to support that, just at face value, would be enormous. And so it's going to be smart technologies and some embedded generation to try and help make that a smooth future.
Well, because one of the other questions I'm going to ask you right now is how much is new technology, advanced technology, and I know we're going to talk a little bit about Dynamic Ratings and the technology that you all are bringing up, but how much is technology changing to adapt to all of these challenges that are going to come about at the grid edge?
It's actually, I think, going to be one of the key parts of it is making the grid smarter. And one of the CEOs of the transmission distribution networks in Australia basically said that in many countries at the moment, major drivers for electrification and renewable development is for energy security, because that's a big challenge globally right now. As the geopolitical frame is shifting a little bit, it's becoming a bit more challenging. And then in many countries, the transition to renewables for a clean, net zero 2050 or 2040 or whatever it might be. Every country's got their own goals. That's driving a massive electrification trend and huge amount of renewables going into the network. And an Australian CEO said that for the network to be able to handle this transition, its capability needs to increase dramatically. I think he said 3 to 4 times the capability. And he wasn't talking about capacity, because capacity means upgrading all the poles and the wires and the transformers and the substations, and like the cost to do that and the effort required to do that is mind-blowing. It's ridiculous. And so the only way we can achieve these goals is by making the grid more capable. And that's through intelligent sensing, intelligent control, computer algorithms making decisions on the fly, doing a bit more energy arbitrage, and sharing your EV charger with my solar panels and their battery system and those types of things. So
they're in, because that was, you keep bringing up things that I want to continue to ask you about. Capability, that is a great point. I hadn't thought about that. That also includes efficiency. Capability includes efficiency. The idea that now you have power at the grid edge, not only when I get my car home, now I'm creating power that I can send back up to the grid. My son in Southern California went from a $400 a month average electrical bill to $23 because he's got solar until he got his electrical car, and now he's back up to about a couple of $100. But it is such a dynamic changing power. It seems to be, from step down. It's step everywhere now. I mean, power is coming from a lot, and capability, making the grid more capable is excellent. I would, as a reliability expert, I'd call it make it more reliable as you make it more capable. So you've just already mentioned some of the challenges that take, but as it relates to specifically dynamic ratings, what are some of the challenges you as a company are seeing? Since you're the product portfolio guy, you've got to develop that product for that future. What are some of the challenges you all are seeing?
It's kind of exciting because I get to move around the world quite a lot and talk to different utilities to hear about what problems they're having, and I'm actively involved in Seagrey, where you hear about the challenges that are happening. And so there's a number of key touch points. One is balancing the network right now, particularly the power delivered to your house, because making sure that power is within limits and it's available when you want to put on a big solar system on your roof, enabling, the network should be an enabler to enable you to have the solar or the EV or whatever it might be. That's really critical. So enabling the network to function correctly and manage power quality and making sure the network is operating correctly down at that low voltage level, serving the customers. That's an area where DR has been doing a lot of work with expanding our monitoring capabilities down into that part of the network and doing kind of unique projects where we're doing control of electric vehicle charges and supporting utilities as they try and understand how they're going to handle these challenges. That's probably a major one. The second one is our traditional business of asset condition assessment and helping utilities eke out better efficiency of use and longer life of their bigger primary assets in the substations, because the augmentation is going to have to happen to be able to support all this stuff, and the cash is not going to be available to be able to upgrade transformers or maintain things quite as frequently, and the staffing isn't quite there the same as it was 50 years ago or 40 years ago. And so that's having more data and more actionable results from monitoring systems is really going to be a core part of DR's future to be able to support utilities through this.
So you just brought it. You keep bringing up my next question: staffing. It just both at the engineering level, so at the mind share and for truck runs, the trades level is probably one of the biggest problems that we got today. People just can't hire tradespeople so we're having to rely on technology a lot more to tell us what's going on, because we're not going to run people out to the grid anymore. You can't afford to go to the grid edge, right? And if you go there, you've got to be very efficient and you got to be very capable. We're going to talk about a product I know that DR has got to do that. But as it relates to just the problem, since you talk to a lot of utilities, what are you hearing about what people are doing to address it? I mean, we can't just say, well, that's a problem, it's going to go away because new people are coming into the labor market. We've told generations of people don't go to technical school, get an engineer or get a college degree. So we have more sociologists driving Ubers than ever before, degreed sociologists, right? But what do you hear about some of the ways people are handling that problem?
It is driven by data and by having analytics and tools to be able to support the reduced workforce and the reduced experience. Because I mean, we used to have people on the tools that had been doing that for most of their career. You know, they'd come through an apprenticeship or an equivalent trades program, and they stuck with that, and they kind of knew everything there was to know about a transformer or a circuit breaker through just sheer depth of experience. And that's gone. That time is finished. But we're now supplementing that with technology and with tools to be able to help people do that. And it feels uncomfortable, I think, initially, because you start thinking about these, the newer generation not having the same depth of experience or hands-on knowledge necessarily. But the reality is that, I came from a generation where I fixed my car a bit. My father came from a generation where he understood every moving part of that vehicle. The next generation probably has got no idea what's happening under the hood, and they don't need to, because the reliability is there, the engine computer is so intelligent, it takes care of so many things, and we've been able to reduce our reliance on intimate knowledge of those machines because they take care of themselves much better now, and there are tools that are much more useful for diagnosing what's going wrong. The same is happening in the power network, where companies like ours and many other companies here are producing tools that can take a wide body of data and turn that into really meaningful, useful results that can direct people to the right place, can reduce the need to have an in-depth knowledge of the nitty-gritty details inside a transformer for everybody. I think those are enabling technologies that are going to really be assistive in dealing with the change in our labour space, for sure.
Excellent. That's that's a very unique way of looking at it, because people on one hand are somewhat afraid of change, technology. Having fewer people is going to drive people to go, we've got to come up with a solution. And there are too many people that think the solution is, just do more training. It's not. Change the system and let the system tell you. There's a whole thing called machine-driven reliability. Let the machine tell you when it's broken.
Yeah.
Don't wait for somebody to go out and do maintenance on it, because he's probably going to break it, right? Make sure the machine tells you that. That's excellent. I want to switch gears a little bit, and I want to go to, so dynamic ratings is developing. Your product development, you know what's coming next. At this Grid Edge event in San Diego, thank you for being here. I'm on the steering committee, so I'm passionate about this, the growth of this. Our next one is in 2025 back here in San Diego, so we'll see you here for that. But what are you particularly proud of that you're presenting at this Grid Edge? And by the way, we have a show and tell for you there beside you, if you want to pick that up.
So this is part of our Connect Grid platform to try and connect the edge of the grid together and bring that data back. So an IoT platform designed for utility networks. This is one system that's part of that, and it's part of those tools that we talked about to help the labour force and help utilities get to their problems much faster. And so this is essentially an intelligent communicating fault passage indicator. It's got a whole platform of sensors on there. These things used to be mechanical flag indicators on a line, and now it's a fully communicating sensor platform that's live connected back to the central advanced distribution management control systems. And the way utilities are using these types of tools to improve how their workforce operates and how their network improves is, instead of having truck rolls and people driving around looking for a flag indicator or looking for a downed conductor, these tools can basically have computer systems that will identify immediately where the fault is to a good degree of accuracy and send a truck to that spot. And so the outage time is reduced, the public safety aspect is dramatically improved. And there's a lot of other condition monitoring data that comes with that in terms of line loadings and swag and sway and all the other things that kind of go with it.
So this just clips on the line, holds tight, not going to move, and then it flashes, but it's also sending signals.
Sending signals back, and it's powered by the line, it's got a solar panel backup. Yeah, the whole thing is
Where's the solar panel?
it's wrapped around the edge of that
Oh,
glass.
yeah,
piece
yeah,
there.
yeah. I see
It's a
that.
flexible solar panel.
When he handed it to me, I must say that I put my finger in there. He said, "Get your finger out. It'll clamp on and it'll kill you." Well, that's brilliant.
Yeah.
Much success with this. I think this is, it's one of those technologies that, you said it, truck rolls. If you can make truck rolls, which people hate because they're very expensive and they're out there looking for the problem, if you can make them more efficient and reduce the cost of labor because you get more with the labor, it's a brilliant solution. But anyway, so thank you so much, Seamus.
No
I
problem.
appreciate it. Good to see you live and
Yeah,
do this. We'll do it
it's really
again
nice to see
sometime.
you in person, so thanks for that.